Alright, this is the compiler, Jane compiler, and we'll look at the basic structure of the compiler. And it gets generated into a text CD2 formatted file, which gives us all the instructions that we need to run this program. So the program is basically these are declaration statements, and then these are the statements. So functions is a statement, function is this is the name, so main goes from statement 0 to 15, and these are the temporary values for that function. Same way here. And then these are all the statements that that program uses to run. In here we have 185 basic instructions for running any application. And this has all the math operations, the assignments, the select statement, the catch, the carry, the try, all the statements are in here. Something complex like a for statement is actually just a bunch of conditionals and some branching. So they're not, so a lot of the more complex statements are complex, not. But these are the primary statements that they all use. So all we need to do is write a function to process 185 statements, and we can run this on any machine simply by reading this file. You don't need a compiler, you can just literally read this thing. Okay, so we look at this. This opcode, ask, colon, divide is one of these opcodes, and that statement is here. So a divided by 3.5, which is 5 is the location of A, 6 is the location of 3.5 in temporary. So temporary is here, 6 is 3.5, 5 is empty right now, but it goes out and finds 0, which is here. This is a find, so I do a find 0, which is A is 0, and I store that result in 5. And then so now 5 math is 5 divided by 6, which is A divided by 6, and that gets stored in 7, and that 7 then gets assigned. Anyway, there's a lot of basic assembler kind of things that are happening, but this whole program is to do that. Now, familiar with what's going on, we do this so that we can run across multiple machines. I can send a machine just this code, and it can run, I can write a very simple C++ or assembler and execute these statements, which is what I've done. I've created a service that'll run that, so now I can just send this text file over and it can run this program. And we have two-way communication, so it can send me text files and I can run those also. So there's a lot more to that part of it, but I just want to show you the basics of the compiler. And some of the extensions, when we get into this, is extending the compiler to allow us to perform some of the operations that we need. And so one of them is opcodes, which is to extend, to use these opcodes that we already have. Generally, we have here an assignment of a star or multiply equal, star equal, which is this statement, B star equals 10. This would be generally multiply B by 10. In our case, B is an array. So here's B, it's an array. So I want to multiply B times 10. Well, in general, we have just one function that says take two arguments and do a multiply on them. Now that becomes complex when we have a couple hundred, a couple thousand types of things, because we could say one's an employee and one's a plane and do all kinds of things from just those names alone. So that's what this does. We can do system-defined data types, and we can do user-defined objects. So if you have an object called person or car, we can put those names in here also, and it will call that function based upon the data type of the particular object. And so here we're looking at B times star. This is an assign, which is this one. So I'm assigning to B times 10. And so the array is B, and it can be either an integer or real. So we take B and we multiply each element of B by A, which is either an integer or array. So we go further, we say, okay, here's C is A plus B. Now A is an array, B is an array, so I say here I have a math plus, I can do an array. If I have an array, it'll call this function, and this function will create a new result, push A and B into it and return that result, and then C now becomes that result. So when I run this, here C is A plus B. And here's B down here, which is B times 10. B is 10, 11, and 12. So now the values are 100, 110, and 120. Change this to whatever we want. So if we come in here and run this, so now we multiplied it by, so we can do anything. The reason we want to do this is because when we run across multiple machines, we're going to have a whole lot of data types and conditions that we want to filter, and we may have to come into a routine because the process is on another machine. We're going to have to send the data over, wait for the data, put it in its proper place, and do all the management for the user so the programmer never has to see any of this stuff. And we can do that through these types of operations. Okay, so those are opcodes. Now, to extend this a little bit more, this is just some of the tedious work we as programmers have to do, which is to break things up by data type. And so here we have another extension that I've added, which is to put in natural language extension into the language. And here we see a language function, and the language function says here's a syntax that is going to make this function up. And in our case, it says the blanks here are treated as and. So it's going to be color and is, but is optional. So the braces is an optional word syntax or array, so we can say you don't need to put the is in there, but if you do, it's okay. And then it says here's an optional, you can put in a color U. Now parentheses says use a syntax of color U, which can either be light and dark. So it's going to look for, the commas is an or, so it's either going to look for a light or a dark, or neither one. But if you put something else there, it's not going to like it. Well, it'll ignore this and go to the next condition. The next condition is it must be a color. So it must be red, blue, or green. So it calls this syntax and looks through and makes sure it's verified. So this whole thing has to be true before this is accepted. So we come down here and we say alert color is dark blue, and color is okay. Color is, and hue is either light or dark, and then red, blue, or green. So I can say red, blue, or green here. And we can extend this. These are just simple examples. So we can also do things like here's an operator times. I can return A times B. So I can use the times or whatever word I want to use to do anything between these two operators. So I could do a dot or a cross or a compare or whatever you want to match or whatever word you want to use. So you're extending your own language and being able to put that in more readable terms. So here's an A equals. Now here's an assignment. These are operators, which takes two parameters. This is an assignment, which does a little bit. It only sends you one, and it's going to put it into A. So it's going to send you 55, and then you do what you want to do with it and return it. And so we can run these things again. And so A equals 5,500. I just multiplied it by, I just multiplied it times 100. I could just act like I just don't like the equal sign. I could say equals or equality or whatever, whatever function you want. So anyway, these are the extensions that I'm going to need when I do multiple machine execution. I need to be able to interrupt, catch these operands. I can say if A is a remote, if I'm going to multiply A and B is a remote value or a function, whatever it is, I can catch it, go get that value, do the multiply, and so on and so on. And I'm hoping to get to a more readable code. We can parse just about anything, and it has syntaxes for all the number formats, proper case, any word, variables. We can extend this so that the compiler does all it. And this is all done at compile time, not at runtime. So no harm done here, because it's, it doesn't matter how long the compile takes. It depends on how fast the program runs. This is our next. I have all this work and I have all these statements. I have 600 some odd changes to the compiler, and now I'm getting ready to do the multiple machine parallel execution handshaking across machines, all at a assignment. And those namespaces were available to me in my program. And my program is available to that remote site, so it can run functions, send functions back to me. I can run those and so on. This is the next phase. Hopefully, the very next phase will be to get all of this to sing together as one application running on any number of machines as a single application. Thank you.